study. And we said that in selecting aspects of the population for our study, there is always the need for us to use sampling techniques, use appropriate sampling techniques. And so those techniques too, we have discussed them. We said we basically have two main types of the sampling techniques, or we have two major approaches that we can select our sample. We said we have the probability way and the non-probability way. We have exposed you to the probability, the various probability sampling techniques, as well as the various non-probability sampling techniques. The focus is to help you use those approaches or techniques in selecting your sample in a way that you can use the data you have collected from your sample to make generalization for your population. And that is why it is always important for us to consider the way we select our sample. The way we select our sample. Now we have seen how we can collect our data. We have seen how we can collect our data. The next thing that we have visited the basic concept in statistics. The next thing we want to do is to visit the concept of how we then organize the data. How do we collect data and organize them? So the unit 2 is on organization of data. I hope we all agree that it is important that when we collect data, we need to organize them in a way that should be, in a way that will make that data more presentable. So what are some of the tools that we can use to organize our data? We can organize our data using frequency distribution tables. We can do that also using pie, bar, and Pareto charts. We can use the stem and leaf plots, or simply stem plots. We can also use the box plots or the box and whisker plots to represent our data. And we also have histograms, which are common. You know of histogram, frequency polygons, then cumulative frequency curve, cumulative frequency curve. So all these data organizing tools we have mentioned, you have actually experienced some of them, most of them already. Maybe the Pareto charts and the box and whisker, those are the ones maybe. As for the stem plots, you have been doing it in your various schools. So the first thing we want to, please, this thing that we are discussing may appear to be very basic, right? It may appear to be basic, but then we are still exploring the basic concepts in both in both statistics and probability. So let's quickly look at the frequency table. This for the frequency table is something that you can all do. I believe you can all construct a frequency, organize your data using a frequency distribution table. I hope you can all do that.
Yes.
But when you are doing it, also consider the ungrouped one. Consider the grouped one. What we have here is ungrouped. So you have to consider the the group 1. So looking at this table that we have here, you clearly see number of hours that some workers work per day, and then we have their frequency. So the frequency is telling us how many works 2 hours per day, how many works 3 hours per day, how many works 7 hours per day. So these are some of the things that, and you see that it is well organized. It is well organized. And then once you have organized your data like this, it is important for you to tell us how many people were involved. Statistics would answer that question. How many? So number. So you have to find a summation of all the sum of all the possible frequencies you have, and that will give you the total number of people that were involved. The next thing that we want to talk about is the relative frequency distribution table. The relative frequency distribution table. In some cases, whoever that is collecting the data whoever that has collected the data may be interested in finding the relative frequency of the various classes. Okay, so in this one, in finding the relative frequency, it is normally the frequency of the suggested or interested category. Okay, frequency of the interested category or class divided by the sample size. Now the sample size should be given. You should be told how many sample size you want to how do we get a sample size? So the sample size should be the same as the total frequency in most cases. Okay. So that is it. So the relative frequency can be written as we have there. When you find the sum of all the relative frequencies, they should give you one, like this particular one. So let's look at this particular one. So you see that we have the hours that they work per day, right? The hours they work per day, and then the corresponding frequency. So these are the hours per day, and then these are their corresponding frequencies. Okay, so if you look at the corresponding frequencies, you find a summation of all the frequencies for the various category of classes. So let's say hours per day, you get 20. So these 20 that we have here, we are going to now divide each of the frequencies by these 20. So if you pick the first class or the first category of hours per day is 2. When we match it to its corresponding frequency is 3. So this 3 divided by 20 will give us the first relative frequency, will give us the relative frequency for the class or the frequency of 3. Each relative frequency is 0.15. Now you do that for the next one, which is 5 divided by 20, and that will also give you 0.25. You try that for the 7 hours per day. You see that the frequency is 1. So take this frequency divided by the total frequency, which is 20. It's going to give you 0.05. Now find the sum of all the relative frequencies we have here. Find the sum of all these relative frequencies we have here. Will you get one?
Yes, please.
Yes, Doc.
So
Yeah.
if we want to now, so you see that this stage, we use this column. The second but last column was used to do the computation. So you can do this on your paper, not in the booklet like this, not on the in the table like this. You can do this in your booklet. Now you bring the result here, or you do it once. Just you can ignore the latter part equal to you do it this way. So we now have the cumulative frequency as well as the cumulative frequency. These are relative frequencies, right? So the cumulative frequency will be the for cumulative frequency. We have not computed cumulative frequencies here, but I hope you can do that. The first one would have been 3, isn't it? If we want to do that, right?
Yes, sir.
Yes, please.
So you can create another. We can create another column, and then you can add the relative the cumulative frequency. Oh, I think we have it here. This is it, right?
Yes, please.
Sir, we
This
have
is
it. It is in the table.
yeah, so it is here already. So this is a cumulative frequency. And then we have the relative frequency. So the table here shows the frequencies. It shows the cumulative frequency, and then it shows the relative frequencies. Then it also shows the cumulative relative frequency. So the cumulative relative frequency is just like the way we did the relative frequency, or the way we did the cumulative frequency. So you add them. So the first one is 0.05. So this 0.05 plus that when you want to get this one, is going to be this one, the 0.15 plus this figure. So that will give us 0.40. Now, if you come here, you can just add this one to this. So that will give you this result. If you want to get this one, you can do it this way. It's going to give you this one. If you want also to get this one, you just add the 1.0 to 0.85. These are things that you can easily do, isn't it?
Yes, please.
Good. And so now let's go to where any question? So we should move on.
Yes, please.
Yes.
So where we have a group frequency distribution table, you see that anytime we have a group frequency or the frequencies happening in groups, you realize that we will have the lower class limit and then the upper class limit for the various groups. So do we have a typical example here? Yeah, so this is a typical example. And so if we pick this one, for instance, we will go back. If we pick this one, for instance, you see that here the lower class limit is 5. And then the upper class limit for the first class is what? For the class 5 to 9 is what?
29.
No, are you sure? 5 to 9. So the upper class limit is 9.
9.
Yeah. How do you find the range?
Subtract the lower from upper.
So what would be the range for these data sets?
24.
So how did you get a 24? That is, you subtracted the 5. This
From
5.
The 29.
Yeah. So from the 29, because the 29 is the largest figure here. Okay, so the largest number minus the smaller number. Okay. What else? Now, if I want to find the total number of people in this class, how do I find it? The class from 5 to 9. So you have the class 5 to 9. Okay. So the class 5 to 9. We want to find the total number of people in this class. How do we find it?
If we want
Can
to
you-
find the class size.
Yes, so I want to find
Yes.
the class size. How
You
do I
can-
find the class?
You can either list them starting from the 5, 6, 7, 8, 9.
I don't want to do it that way. That will be too elementary, isn't it? What if the class is so big? Let's say we have 5 to 99.
Sir, please, you find
You subtract the upper class limit from the low. You subtract the lower class limit from the upper class limit.
Oh, so you mean that the class size? So class size will be equal to. So you are saying that upper class, right? So upper minus what? Lower. I hope you heard him. Limit to.
lower.
Yes, sir.
Yes. So let's see if that to be true. So that will give us what? 9. 9 minus what? 5, right?
Minus 5. Yes, sir.
So you get what?
4.
4.
Which is wrong.
4.
That is wrong. That is not the class size of this class.
So
Okay.
it's
So it's wrong.
lower plus upper minus lower plus 1.
Okay. Upper plus lower minus 1.
Plus 1.
So let's go. So let's go up here. Upper. So that is upper plus lower.
Upper
Plus
minus
1.
lower plus 1.
Ah, why are you doing that? So I see this is my first time hearing it. But we are here to learn. So
Okay.
upper plus lower plus what?
1.
Plus
No,
1. Okay.
upper minus lower.
Oh, upper minus lower. Okay, so
Yeah.
okay. Upper minus lower. So upper minus lower plus 1, right?
Yes, sir.
So that will give us 4 plus 1.
Yes, please.
And that will be 5. Where did we get that information from? That in finding the number of people in the class or in finding the class size, we do it as upper minus lower plus 1. Why not plus?
Sir, please.
Why not plus 2? Why
Sir,
not plus
looking
2?
at sir, I use my assumption.
Hello, sir.
We want a mathematical assumption. Mathematical assumption will always work in all cases, right?
Hello, sir, please. Hello, sir.
Hello, sir.
Yes, those of you in UCC, how did we say we'll find that?
Sir, please, let's go back to the table so that I'll see. I said
Yeah,
this one.
this is the table. So this is the table.
I said you pick the second line. The second line. Then it's lower class is 10. Then you subtract the first one, which is the first limit from the 10, making 5. Or you can choose to use their upper ones, 14 minus 9. So it is either 10 minus 5 or 14 minus 9. You're going to get that what you are looking for.
What if the class are irregular? They are not regular.
Sir.
Hello, sir.
Yeah, who is calling?
Sir William.
Yeah, William.
Sir, I want to suggest this. Because it's 1. The reason why it's 1 is, if you consider the class boundaries, we reduce it by 0.5 for each lower limit. So that half will together get the 1, reducing it and then increasing it.
Hello, sir. Can I come in?
Yeah, I get you. Can we Can we settle on
Hello?
that so that we move on?
Hello,
Can we
sir.
settle on that and move on? Yes.
Okay, so the class width is the same as the class size, right?
Yes.
Right. So I think we find on the frequency, I think the frequency is 20.
Sir.
Eric, we are listening to
No.
you.
Okay.
So we divide the frequency, that is 20 by, from this question, I learned we have to group it into 5. So we divide by 5, 20 divided by 5, you are getting 4. Then we start counting from the smallest number, we start counting from the 5. So 5, 6, 7, 8, 9. So we are going to get 5 each. I don't know.
Hello, sir.
Raise your hand. Raise your hand. Next time, if you don't raise your hand, I'll not mind you.
That's which.
Eric,
Hello,
your
sir.
hand is up. Yeah, Eric, your hand is still up.
Over.
Yes, sir.
Can we, Eric, are you done with your submission so that we call somebody else?
Okay, sir, call someone else.
Okay, Abeku Smith. Abeku. Teacher Abeku. Oh, Teacher Abeku can't hear us. Okay, Sheriff, Arab. Yes, Sheriff.
Yes, so I think we'll use the class boundary. So if we are looking
do you
for
think that to be safer? Okay.
Yes.
So go ahead and do it and let's see.
Yeah. So when we take the first one, the class interval, the 5 to 9.
Yes.
I think that one will just use the 9.5 minus 4.5. So the class boundary minus the lowest one.
And it will give you what?
So we'll get 9.5 minus 4.5.
Okay, so I think we can make a decision on that. In finding the class size is more appropriate. Yeah, Abeku.
Yeah.
Abeku, your hand is up.
Yes, sir, please. I think I'll subtract the first class limit, first lower class from the second lower class.
Or
that is on the table. I'll subtract 5 from 10. Or I'll subtract the 9 from the 14. I'll get the class size.
Okay.
And for that one, it will work for all. If you take the lower class limit of the first one and then the lower class of the second one, you subtract the first one from the second one, which is the 10 minus the 5, you're going to get the class size or class width.
Okay.
Thank you.
So you're welcome. So that will work. Okay. But the conventional one that we usually talk about is where we subtract the lower class boundary from the upper class boundary. Yes. But the observation you have made will also work. So that is true. A little before we come back again, let's see. So did I hear somebody's hand is up? Was somebody's hand up? Okay, good. So that is that. We were not even where we were talking about. We were not there yet, but we just want to find out whether indeed you have the ideas already. So we have seen how we can find a class size. We have also seen how we can find a the range. We said the largest minus the smaller, or the bigger number minus the smaller number. Then we've also seen how we can construct a frequency distribution table. Now we have 2 types of class intervals. So in talking about the class intervals, we have inclusive class intervals and exclusive class intervals. And you must pay attention to these categorizations of the class interval, because you can be asked questions can be asked on them during your quiz and so forth. So for the inclusive class intervals, values equal to the lower and the upper limits of the class are included. What it means is that when we come back to the table, this table, no, where is that table? There. So we'll get here, for instance, this one. So if you are looking at inclusive class interval, and the class starts from 5 to 9, for inclusive, we'll include numbers that are equal to 5, which is the class limit, lower class limit. And we also include numbers that are equal to the upper class limit, which is 9, right? So what we are saying here is that when we pick the class 5 to 9, and we are using inclusive class interval as a case, for instance, we are going to include all numbers that are equal to 5 in that class, and we are also going to include all numbers that are equal to 9 in that class. That is the inclusive class interval. If you go to 10 to 14, the class 10 to 14, if we are using inclusive class interval, it starts from 10, numbers from 10 to what? 14. But if you are using exclusive, then we will not count the 5, the numbers that are equal to the lower class limit and the numbers that are equal to the upper class limit. That is what the exclusive class interval does. So look at what we have here. So exclusive class intervals, items equal to either the upper or the lower class limit is what? Excluded from the frequency of that class. So if you are trying to get the numbers that belongs to that class, for you to talk at the frequency, you exclude those that are equal to the upper limit and the lower limit of the class. Please, I hope that is clear.
Yes, please.
Yes, sir.
So the next thing that we want to do is this activity. This activity want us to make a frequency distribution table for the data using 5 classes. So we want to use 5 classes. Before we come here, I think how you can find a class size, okay? How we can find a class size. So if you look at this slide, it says that the number of classes is, if the number of classes is not given, you know, sometimes, most of the time, the number of classes will be given. For those that we teach them at the SHS, do you see that they will say 5 to, so they will start with a few of them, maybe 0 to 5, or 0 to 4, 5 to 9, 9 to 10 to 14, right? Or 10 to 13 or so something. So then they will bring dot. So they most often they usually start for us. But what happens when the classes, how do you call it, the number of classes is not given? Okay, the number of classes is not given. Usually you have to form, the number of people in the class should be 5 to 20. Usually 5 to 20. And so if it is not given, then you have to find the class width. So that you need to find a class width. That is the largest, the range of the data divided by the number of classes. And then you run it to the nearest whole number. Let's use this as a case to get that right. So if you come to this data where we have the lowest number to be 5, and then the larger number to be 25. So I hope that is right. So if we want to find a range, That will be 25 minus 5, right? And we'll get 20. Now, the formula says that to find the number of people that are supposed to be in that class, we should divide the range by the number of classes that we want to form. Here they say we should form 5 classes for this, 5 classes for this data. So 5 classes is the number of classes is given, but the people that are supposed to be in the class, we don't know. 5 classes. So that would be 20 divided by the number of classes. Okay. So the range divided by what? The number of classes will be 4. But you see that the 4 does not lie. The 4 is not within the range that we stated here. That usually the number should be between 5 and 20. The number should be between 5 and 20. Okay. So because the 4 is lower than 20, we run that to the nearest range that is supposed to be acceptable, and that is 5. So that is why here it was rounded to 5. So they said the class weight will be 20 divided by, that is the range divided by the class, the number of classes we want to form, and that is 4. But we need to run up, so we would use 5. We need to run up because we needed 5. Our classes would be 5 to 9. We'll start from 5 to 9, 10 to 14, 15 to 19, and so forth. Yes, there's a hand up. Let's see. Foster.
Daddy.
Any observation?
Yes, my concern is running it to the 5. Why?
Because if you look at we said that usually, does somebody want to answer that question? Do you have somebody among you who want to react? So you can react, then I can. Yes, Dominic.
The reason why it was run up to 5 is we said after getting the number of people in the class, it should fall within the range we are having. But per what we had here, after dividing the range by the 5, the number we had was 4, which is not up to the range we were having there. And the range started from 5, and there's nothing like 4 in the 5. That is why we ran it up to 5, so that we can get that
Thank you, my boss.
in the class.
Thank you. I'm grateful.
Okay, so I think it has been clearly articulated. If you look at if you look at the numbers we have here, none of them start from 4, isn't it? But I think the underlying factor is where the range is given. It should lie between 5 and 20. So the least number we can get to be 5, and we had 4. So it means it doesn't fall within the range. Now, the next thing that we have to look at is to, yes.
So please, I have a question.
Okay.
So my question is, looking at the list of the numbers over there, the least number there is 5. But assuming after calculating and we get maybe 3, and even if you add 1 to it, we are going to get 4, which doesn't also fit the numbers in. What are you going to do about that?
So you have to keep running. It's an estimation. You have to keep rounding so you get the least requirement. So you have to run. You know, sometimes when you run at the first instance, you may not get there. You must run a little bit again. So yes, so that is it.
Okay. Thank you very much, sir.
You're welcome. Okay, so let's continue. Please, some of you are producing feedback. I can see some hands up. Let me take Penny.
Sir, please, I want to know why we started from 5, but the interval shouldn't be, the interval was not 5 to 10, but 5 to 9. What is it?
Yes.
I said I wanted to know why when we started from 5, we didn't. The interval was not from 5 to 10, but 5 to 9.
Okay, so how many people do you want in the class? How many people do you want in the class? So let's see, 5 to 9, now 5 to 10. We needed how many people? 5, right? So
Yes,
let's
please.
see. Yes, so
4.
we needed 4, right?
Yes.
Okay, we needed 4. So if we needed 4, check from 5 to 9 and 5 to 10 whether the 4 will be which of them will be the appropriate thing to
When I start from 5, 6, 7, 8. If I add 4, am I going to count the 5 included or?
Oh, but if you look at, I think we said that let's get this right. We mentioned that we needed at least, let's look at this one. I think it was given. There was an information given. Let's look at the instruction. It says the data below are the marks of 20 students who took a quiz in mathematics. Make a frequency distribution for the data using 5 classes. So it's the number of classes that is given using 5 classes. And if you are using 5 classes, then the 5 classes, we said that if we want to, we need to get a range. So the range is 4, right? But we rounded that to 5. Now, if we do it 5 to 9, let me see, 9.5 minus 4.5, that would be how many people? How many people are in that class? 5.
5, please.
5.
So that is 5. And the one who has the question,
it should be 9.5 minus 5.5.
Hey, why? No. You are subtracting the 0.5 from the 5, and you are adding it to the 9. Yes. So the one who asked the question, can you ask the question in another way?
So I was asking the range. No, the interval.
Yes.
That is this one. They said they started from 5 to 9, but can I also start from 5 to 10?
Is that a question you are asking?
Yes, please.
Class, what do you think?
Why not 5 to 10, but rather 5 to 9?
Hello, sir. Please, can I come in?
Yes, you can.
Sir, please, if I'm helping with what the question says, I'm using 5 classes. So if you pick the first one, which is the 5, you count from 5. 5, 6, 7, 8, 9. You got the final. As soon as you get to 9, then you've gotten 5 of the classes. So that will be 1. So if you want to continue from the next one, it will be 10, 11, 12, 13, 14. That one you're going to get 5 classes. Hello, sir.
Yeah. My worry.
If my colleagues are hearing me, for the 5 classes that the question is saying, when you start from the 5, the first number, which is the 5. 5 is part, so it is 5, 6, 7, 8, 9. So when you get to 9, we won't say when I want 5. When I want 5, and here back. That's why we ended at 9. And the next ones will start from 10, 11 up to 14. You're going to also get 5 in the middle there. Thank you.
So, yes. Please, are you clear? Please, the one who asked the question, have you been answered?
So I'm clear. Let's move on.
Are you sure?
Yes, please.
So I think to add to what he said, the 5 to 9 is also used to avoid overlapping. You see, if we make it 5 to 10, it's going to there may be some overlapping at one point in time. Unless maybe we start from the beginning, 5 to 10. Then the next one will be what? 11 to
16.
11 to 16.
But
Then
that will
17
not
to
that will not be the best. You see,
exactly.
usually when we like this one, the class before this one would have been 0 to 4.
Yes.
Then 0 to 4, then 5 to 9, then 10 to 14. You get to 15 to what? 19 in that order. So you see that this one, the intervals you check and see. I think that it's clear. You see that the class limits are consistent.
Yes,
So
if I'm
that is
getting
it.
things right, that means that if we run it off and we get the 5 at the interval, when you're counting, you have to start from 5, 6, 7, 8, 9, giving you 5 interval.
Yes,
right?
yes,
Okay.
yes.
Okay.
So my worry now is our interpretation of the classes. Are you getting it?
Yes.
And then the number of people in the class. I am getting the impression that we are trying to, you see, the class interval, that is the number of people in that class. The number of people in the class is not the same as the classroom.
Yes, please.
The class is from 5 to 9. And the number of people in that class will tell us the size of the people, the size of the class. Mathematically. Are you following? So
yes,
it is the class size that is 5. Are you following?
Yeah.
But the number of classes they asked us to form were 5. They said we should form 5 classes from the data given. So count the number of classes that we have there. If it is more than 5, then it means we are wrong.
It's 5.
Please, are you following? Is it not 5? So
Yes,
the
please.
first class is those from 5 to 10. They form the first class. The second class is, no, those from 5 to what? 9. The second class is from where? 10 to what?
10 to 14.
I'm looking at 10 to, then
10
the
to 14.
yes. So these are the classes. So we should get 5 classes like we have here. These are the 5 classes. These are the 5 classes. The first class is the first one, second one, third one, fourth one, fifth one. But the class size is 5. Is that okay?
I said I can also start from 5 to 10, 11 to 15, 16 to, and then get same 5 classes.
Would the class
and then make it 25 to 30 and
The
get
class size will be certain.
No, that will be 6.
There are
You
no
will
values.
not like
There are
that.
no values above 30. So it's going to be a problem.
So can I come in?
So can we move on? I hope this one we are clear on that. Can we move on?
Yes, sir.
Yes, please.
Elliot, any different thing? Della, any
Yes, sir.
different thing? Yeah, Elliot.
Hello, sir.
Yeah, Elliot.
Yeah, when we were in secondary school, we were taught that to find the intervals we did earlier, you will check the range, and then from the range, you divide it by the number of classes that you want. So that will be the class interval. So here, you realize that the 5 will be our class interval. So when you count from the 5 to 9, the difference will be 5, as my brother did earlier. So the difference is supposed to be 5. The interval between the upper and the lower is supposed to be 5. That is, you count from the 5 to 9. That's how come we start from 5 and end at 9.
And that is inclusive class interval, isn't it?
Yes, please.
We were using the inclusive class interval, right?
Yes, sir.
Okay. So I think yes, it's okay now. We can move on. Now the next thing is the class boundary, which we have also reminded ourselves on. Then the class mark. At some point in time, as we move on, we'll be using the class mark. And I hope we can all find the class mark as we are here.
Yes, sir.
Yes, sir.
Okay, so can we get one of you to just volunteer and tell us how he can find that if he's wrong, that is what he thinks, how he can find a classmate. Joseph,
So the class mark, I will add to find a class mark, I add the what do you call it? The boundary, that is 5 plus 9 divided by 2. That will give me the class mark.
Okay.
The interval, so 5 to 9. I add a 5 and then add to 9. 5 plus 9 giving me 14 divided by 2, giving me 7 to get a class mark.
Is it the consensus of the class?
Yes, sir. Yes, sir.
Okay.
Yes, please.
Now, yes.
Doc,
Yes.
I think at the SHS level, the class mark, if I'm to say, then we can say that it's also the same as the class midpoint.
Yeah, you are right. You are right.
Yeah.
You are right.
Yeah.
I like the way you are saying from SHS, from SHS.
Yeah. Yeah.
Hello, sir.
Thank you, sir.
So none of you are from the O level. So I don't have a mate among you.
No.
We did A level. We did A level. Yeah, A level and O level. But don't worry, SHS. You are welcome. SHS, you are welcome.
Yeah, we are SSC and then what's
okay, that's fine. It's your time. Your time is now. Yeah. Okay, so somebody was saying hello, sir. I heard some beautiful voice. Let me go to that student who want to. Is it Eric Ahin?
Yes, please.
If okay, Eric.
Yeah, please. I also added the class boundaries to get the class mark. Is it also correct?
It's not good. Don't do that.
Oh, okay.
You see, it's because we said the class mark is the same as you see, when they say the class mark, it's like the average of the class. Did you get it? And the average, there are two class that is the upper limits and then the lower limits. So the average of that will be the class mark, and that's why it's appropriate to say that class midpoint. So why will you go and find the class boundary before you now find the average of that, when you can straight away find the average of the what? The upper class limit and the lower class limit? Are you getting it?
Yes, sir.
Yes, sir.
So that is why I will not suggest, even though you get the same thing, I will not suggest that you tell your student that it is a long way.
Okay, sir. Thank you.
That's yes. Can we move on?
Yes, please.
Yes.
Okay, so the next thing that we want to do is to we are still in the era of organizing our data. Now we have a data which tells us the hours that some workers have worked per day, and then their corresponding frequencies. Okay. Now, can we represent the hours that the workers have worked per day and their corresponding frequency? Can we represent that data using a pie chart? Can we do that?
Yes, please.
Yes, sir.
Yes, sir.
Yes, sir. Yes, we can do that.
Can one of you tell us why you think it's very feasible for this data? Assuming that the data we have about 30 or 40 workers. No, I say for how do you call it? We have the hours. Why do you think this one, for example, is feasible using pie charts? Is feasible? Yeah, I saw a hand up. I heard of a certain Anof. Anof has not spoken this morning. Anof.
Yes. So once we have the frequencies, and then we have been able to calculate the angle of sectors, as long as the angle of sectors is equal to 360 degrees, we can represent the values in a sector form. So that when we draw a sector for 54 degrees, we draw a sector for 90 degrees, everything will be beautifully done in the circle. and then we can name the values as well inside there.
Okay, so yes, that's a good option. Any other? Why do you think this data it will be good? Will be good for pie charts?
So answer Apple.
So who say answer Apple? Can we listen to Williams?
Yes,
so I don't know who raised their hand first. William.
Okay, so so in fact this one is a tutorial form. This one it's actually spelled out the shifts, and the shifts actually will tell us who is doing more hours and who is doing less. With just an observation, you can simply predict. So with pie charts, the sectors will give the extent to which each worker work per day, and that is the simplest way to analyze such a data or organize such a data.
I'm asking that what is so unique about this data that you think representing it with pie chart will be the best? That's the question I'm asking.
Hello, sir.
No, hey, I haven't called you. Let me call you first. Yeah. So Abeku.
Yes, sir. Sir, please. The table is already grouped already. From where we have the angles will not be part of the question when it's being given.
Yes.
But the raw table is a group data. It has been grouped already. So once we have been grouped already.
Wait. Hold on, Abeku. Did you say it has been grouped? Look at it again. Have you taken your breakfast this morning? Look at the data again. Has it been grouped? Say that it has been organized already.
Okay, sir. Thank you. Thank you for
correcting. It has been organized. So now move on.
Yeah, it has been organized already. And secondly, if you check the frequency, the total frequency, you can see that you can divide the total frequency with 360. It's going to leave no remainder. That's what I used to do. If the total frequency I divide by 360, it won't give me any remainder. That means I can use the pie chart to represent because it's being organized already as well.
I make we new dream.
Because
in some cases, you see, I can give you a data that when you find the total frequency and you are trying to find the ratio, those you want to do those division, it will not be exactly divisible. Okay, the total frequency will not exactly divide the 360. Are you getting it? But that data can be represented using how do you call it, the pie chart. So that is not a very good thing a good way to go, because if you are doing that, then it means that if a data is given to your student and the examiner says that, or YX says that they have to use pie chart to represent the data, and it turned out that the total frequency cannot exactly divide 360, then the student will say that we will not do it. Why? Come for your questions. Government, go, mark. Give me results. If you don't give me results, you see. But what I want you to say here is that, you see, pie chart is most often good for ungrouped data, okay? And it's also very useful for categorical data, like what we have. You see, they have put them in category. We have those who work in 2 hours, those who work in 3 hours. So those are the categories with their corresponding frequencies, okay? But the observations, if you look at the number of categories we have here, they are not many. So if assuming that the number of hours that we have here, they are about 40. So we have up to 40. Representing with a pie chart will not be very feasible. Okay, it will not be feasible because we have to think of using other data, other graph to do that, right? So we can, that one we can even use how do you call it? We can use the bar chart, bar graph or bar chart to do that. But if you look at this data set, there we have fewer observations with their corresponding frequencies, and the pie chart will be feasible. Yes, let me go to Abeku first. Abeku, Joseph, your hand is up. Abeku, is your hand still up or is an old hand?
Sir, please, an old hand.
Okay, now let me go to Joseph. Joseph.
Sir, please, for the pie chart, you were saying that because we used to represent data categorically, right?
Yes.
Mine was on the frequency distribution table. I want to ask something. Why is it that we always subtract low 0.5 from the lower class boundary and add 0.5 to the upper class boundary?
Yeah, so the questions to all of you. Why do we always subtract 0.5 from the lower class boundary and add it to the upper class boundary? Any? Please, you can raise your hand and then I'll call you. Yes, Kweku Wama.
All right, thank you, sir. Now let's consider the demarcation of a plot. You always see that where one plot ends is exactly another one starts. So there isn't any gap in between the plots. That is exactly the class boundary. So it means that where one class will end, next class will have to start from there, so that there wouldn't be any gap in between the classes. Thank you.
Okay. Any other? Please, any other? Oh, nobody is minding me.
Hello, sir.
Yes, nobody is minding me.
Hello, sir.
Have you raised your hand? Even though you are minding me now, have you raised your hand?
Yes, sir.
Okay, Williams.
Yes, sir. Sir, I was reading something here. It was saying there's always 0.5. So he shouldn't put it in his mind that always the class boundaries should be less by 0.5. At times it's even 40. And per what our brother said, it actually bridges the gap from the class max. That the intervals that will be given to us, it bridges that gap. If we look at the table, you said that 5 to 9, and then the next class starts from 10. There's a gap there, 1. So with class boundaries, we do that to bridge that gap, so that where one class boundary reaches, the other starts from there.
That means I can also subtract 0.4 and then still break the gap, right?
Depending on the question. It depends on the question. It's not always.
That is why I'm asking. Is it always why? How are we going to do to know the class? Which one should be added?
How do you call it? Is it Williams who is asking the question?
Atta.
Who?
Atta.
Atta. Kwame Atta. Joseph. Yo, Kwame Atta. Thank you for your question. But you see, we don't want to make it look like people are not asking good questions. It's good you ask the question because one day your student will ask you the same question. Now, let's look at Kwame Atta's 0.4. So subtract 0.4, add 0.4 to the other side. You see that when you look at it very well, it will not give you 1. Isn't it? Now, there's 0.5 that it is an observation they have done, and it's conventional that when you subtract the 0.5 and then you add it to the other, how do you call it, side, eventually you haven't done anything. But if for instance, the for the 0.5, that subtraction we have been doing, for the sake of continuity, okay, so normally the gap between the consecutive integer, so you look at the gap between the consecutive integer,
Yes,
and
sir.
then you find the average of that will give you the 0.5. That was the observation they've done. So for instance, when you have 9 and 10, okay, you subtract 9 from 10, you'll be left with 1. That 1, you divide it by 2. It will give you the 0.5, isn't it? But the problem here, why that approach is that we want to treat the classes continuous so that at any point in time, they may not, you see the classes, they continue. If you look at the classes, if you look at the school building, okay, so that is what your friend said, is using the scenario of a land. So you see, the classes are together. So for you to know where the other class, you have to subtract that 0.5, that joins them, and then you add it to the other one to make it inclusive. So to make the classes continuous, we convert the class limit into the class boundaries. That's why we do that, by subtracting 0.5 from the lower class limit and add it to the upper class limit. One other way that you can also look at it is that most often when you look at to avoid overlapping, okay, we also have to do that so that we will not. So the fundamental idea here is that it is plus or minus 0.5. So the plus or minus 0.5 converts inclusive class integers or class limits into continuous class boundaries. So we are only converting them into continuous class boundaries. Okay, so the class limits, they are not continuous, but the class boundaries are continuous. Anytime you see something 0.5, 0.1, those are continuous, how do you call it? Continuous variables or continuous measures. I hope you agree to that.
Sure.
So the class boundaries are continuous. They tell us that the classes continue. There is no discontinuity. Can we move on?
Yes, please.
So some of these questions you're asking, they are nice questions. When we close, ask AI.
Yes, sir.
Good.
Please,
did I call you?
Sir, my hand is up.
I didn't call you, and you call yourself. Is it Williams? Is it Williams?
Yeah. Yes, sir.
Okay, Williams. Sir Williams.
Yes, sir. AI was saying something. It defines the intervals. That's the first one. And secondly,
it does what? It does what?
It does defines the intervals.
Yeah, so it defines it, means that it makes it clearer.
Clearer.
Yeah, yes. It specified the yes. So then what else?
It avoids overlapping.
So it doesn't make the class 1, class 2 over. Yes. So it's separate. When it's
the third one says it handles continuous data.
So the class boundary that we have makes the classes or that data that we have there continuous. So we want to treat them as continuous so that we can deal with them as such.
And lastly, it improves accuracy.
Yes, it improves accuracy and doubts. It clears some doubts.
Yes.
That's why when you want to use the class limit, that if you are 5 to 9 and you want to find a class size in that class alone, look at using that class alone without considering subsequent or preceding how do you call it, classes. You see that you get it wrong. So if you just do it, you consider just the class 5 to 9 and you do it 9 minus 5, you get 4. By natural fact, the class size, the number of people in that class, they are 5. Okay. So that is that.
So we are okay. Let's move on.
Okay. So now that you can be given a data set where you have to convert it or represent that data by organizing your data. You organize that data by representing it graphically. And but that graphical representation, you are specifically interested in the use of the pie chart. So you need to make sure that, yeah, the pie has been drawn here. I thought we'll draw our own pie. So you look at how nicely it has been done. So from getting these percentages for the various sectors, so the work 2 hours per day, 2 hours per day, 54% of the workers work 2 hours per day. 90% of the workers work 3 hours per day. Oh, these are degrees, right?
Yeah,
these are degrees. Yes. So sorry, these are degrees. So if they are degrees, yes, we can convert this to percentages as well. But these are degrees, so we cannot be making. So we want to say that 54 degrees in terms of the proportion of the pie. Okay, the circle works. 54 works how many hours per? Yes, 2 hours per day.
2 hours.
52 degrees. So this is how it is. But you see, this one, you can equally name the sectors within the circle. You can name the sectors. But you see, they have used a key. We have used a key to make it so nice, like as it is here. And the pictorial representation, that doesn't mean as you should also go and use pencil. No, if you have colors, please take your time and color it nicely. If you don't have colors, just do it well, organize the data, represent it using the pie chart, and name the sectors. Can we move on?
Yes, please.
Now the same data set that we have, let's see. Now this is the pie charts. Now we mentioned that we can also use bar graph. Bar graph. So where the categories are not many, bar graph is very feasible. Bar graph is also feasible. So this one, you see that we have, how many bars do we have here? 6 of them, right? So 2 hours with their corresponding frequencies. So the 2 hours, the frequency is 3. Is it correct? The 3. Let's check.
Yes, please.
Okay. So you have it. You have the edition, isn't it? I've given you the slides. Today we will give you. I need to get the other slides for this one. Then we can share some of them with you. Then you read ahead. Yes. I think somebody's hand is up. Abeku. Abeku, your hand is up. Is it an old hand?
Hello?
Yeah, Abeku.
Sir, please, should you be given a data for it to represent? And can you decide to use the bar chart or the pie chart? Or you have to go by, like, you've been given a data to represent.
The question will specify.
Okay.
And UCC questions are not ambiguous. And the one who set your question, is very good when it comes to setting questions. Dr. Yapa, he'll give you the questions that you want. Just pray for him. And clarity, concise, succinct. It will be very analytical and it will be very worthwhile. Yes. When you are answering the questions, you know that yes, you are answering good questions. And you continue to pray for UCC. So this is the bar graph. So we have the various categories with their corresponding frequencies that has been shown. But one interesting thing that you have to notice is that with the bar graph, we have equal spacing between the bars. But that of the histogram, there is no spacing, right? And usually when you don't start from 0, you are supposed to use some the breaking line. No, is it the sigma, that sign, right? You are supposed to use it. Please, I hope you are getting what I'm saying.
Yes, please.
I mean this sign.
Yes, sir.
Okay, let me
Yeah,
see.
on point.
So I mean, since you are not starting from 0, we normally the graph start from here, right? Hey, what am I drawing? Hey, what is that? Do you see it?
Yes, you are drawing line. Inshallah.
That is
Inshallah.
so that is when you are now learning how to use I'm using the device that you can use to write online. That's why. Oosh. So you make some zigzag sign here. That's what I mean. And you know what I'm talking about, right? So it makes some zigzag sign there. And the next thing the next graph we want to consider is the Pareto chart. Pareto chart. Please, I want you to take this opportunity to go online and find out how the Pareto chart could be constructed. Okay, how can we organize our data using Pareto charts? And an example, okay, of a data that can be represented using the Pareto chart. And when you come back, Arnold, is it Arnold, Emmanuel? Arnold.
Yes, please.
You chair the session for 5 minutes after they have made their inquiries, okay, for them to make their input, share their input with us. After sharing their input, then you hand over the mic to me.
Yes, please. 5
to 7 minutes. They will talk about the Pareto chart. What is it? How is it? Why is it useful? Okay, in organizing data.
Yes, please.
Okay, so I'm handing over the mic to you for the meantime. Then after they have talked about it, after the 5 minutes search, then you also hand over to me when you are finished talking about brainstorming with them. All right, so see you. I'm here with you, but I want to hand over. I want to empower you, so that's why I'm giving it to Arnold. All right.
Yes, please.
Please, is the assignment clear? Is the task clear? Pareto
Yes,
chart.
Yes, sir.
Maybe some may not, the Pareto chart, right? Some may not be very comfortable with the spelling. So let me quickly do this. Yes, and then put it here rather. So we are talking about Pareto charts, right? So we can bring that after this. So how do we go about the drawing of or representing our data using Pareto charts? An example, look at example from wherever your source is coming from. Okay, so Anof, I'm handing over the mic to you.
Yes, sir. Please, so we have 5 minutes to do the research. So when we are done and you have made any research, you put your hands up so that I can call you. Okay, class. So please, the 5 minutes is over. So if you have some submission, you can raise your hand so that I can call you. Hello.
Yes, please. We can hear you.
Yes, please. Tiniba. Tiniba, please. You can speak.
This my name, no. The way people they call it, no.
This is our first time meeting, so maybe the next time. Please, how do you mention the name?
It's Tuniba.
Tuniba. Okay, that's fine. So please, you can bring your submission.
According to Chat GPT.
Yes, please.
my source is from Chat. So they said, what's even the name of the artist?
The Pareto chart.
A Pareto chart is used to show which factors are most important by combining bars and line graph. The bars show frequencies and the line shows cumulative percentage. So they give me the steps as to how to represent data on a Pareto chart. They say first, you need to collect the data first.
Okay.
So after collecting the data, you list the categories and their frequencies.
Okay.
So for example, if I have A as the category, then the frequency is 40, B 25, C 20, D 10, and E 5. So it means that I have collected the data and I've listed the category values with its frequencies. Then the step 2 is arrange the data in descending order. So the descending order starts from the highest frequency to the lowest. So if the frequencies are listed, that's 40 plus 25 and others. So you find the total frequency, you add all the frequencies. Then after that, you calculate cumulative frequency. I mean, we all know how to calculate the cumulative frequency. You add the frequencies cumulatively. So from the first, if the frequency is 40, then you add it to the subsequent one and you continue.
Okay.
So the fifth step is they say convert cumulative frequency to cumulative percentage.
Okay.
So it means that the category, the cumulative frequencies, I will pick the cumulatives and we convert them to percentages. Then after that, we draw the Pareto chart. So first, you go in for the horizontal axis. So unlike a bar chart, the horizontal axis takes the category values. So the ABCD will take the horizontal. The vertical axis to take the frequency. That's the frequency will be on the vertical axis.
Okay. Did they talk about the percentage, where the percentages will be?
Yes. So that's the left vertical and the right vertical. So it means that over here we have two verticals.
Yes. Okay.
One at the left side and the other one at the right. But at the right side, the cumulative frequency, the cumulative percentage will be on it.
Okay.
And the left one will take the frequency.
Okay. Okay. That's
and then
very
we
good.
draw the bars for the frequency and we plot points for cumulative percentages and join them with a line.
Okay.
So the figure will be like we have bars and lines.
Okay. So we have a bar graph and then we have the line graph as well. All right. Please, any other person? Hello. Any other person, please? Please, any other person? Yes, Foster.
Okay, thank you so much. I think, okay, from what my brother just said, we can also say that looking at the graph, the most relevant one will take the lead. And if it's a problem that they are causing, at least you seeing the graph alone, you'll be able to predict the cause, those who are causing that particular problem. If there is a particular impact for positive, then we can know from seeing the graph. As my brother during the part said that looking at even the graph alone will tell you maybe the dominance in that particular graph. So here to looking at the graph too, with the one coming the first will tell you that if there's impact, they are bring the impact, whether positive or negative. And if it is negative also, and in the taking decision of it, and you want to solve a problem, solving the problem would lie just between 2 to 3. That's the first to the 3 at least. When that problem is solved between the two, about 75% is solved. So when you go to the parental graph, that is the bar and the line graph, it says that it has a rule of 80/20, meaning the 80 they are the causes of it and the 20 they are the least among it. Thank you.
Okay. Thank you very much. Please. Yes, so we have Elizabeth. Elizabeth, please, you can talk.
Okay, I also want to talk about the principle of Pareto, which is about 80, which says that 80% of your results come from 20% of your revenue.
Okay, that's very good.
Added to what my brothers are saying, then some real life situations include, let's say, when we come to business, 80% of the work is carried out by 20% of the employees.
Okay.
So that is about the Pareto principle. And then secondly, 20% of motorists cause 80% of accidents. So that's what I also want to add to what my brothers have said.
Please, any other? Please, any other person? William, please, if you have something, you can say it. Else, kindly mute your microphone. Yes, please. Who else has a submission? Okay, so we have learned that the Pareto chart is also a way that we can also display data that we collect when we are doing our research. And like our sister said, it is coming from the principle that 80% of effects come from 20% of causes. Our first brother mentioned that when you want to construct the Pareto chart, we are going to get a bar chart and then a line graph. Then he said that we should, when we are about getting our Pareto chart, first we would have to list the data that we want. After listing them, then we will have to record the frequencies that the data points came with. When we are done with recording our list and then the frequency, then we would have to arrange the frequency in descending order. It is very important. It helps us when we are doing the graphing. Once you are able to arrange your frequency in descending order, then you calculate the cumulative frequencies. Once you are done with calculating your cumulative frequency, then you convert the cumulative frequency to percentages. It is the plotting of the line comes from the percentages, the cumulative percentages. So once you know your frequency, you use the frequency to plot the chart, that is the bar graph. Then you use the percentages to plot the lines. Okay. Thank you very much for this opportunity. Doc, please, if you are still on, you can take over, please. Hello, Doc. Hello, Doc. Okay.
Yeah.
So one thing I also wanted to mention about the Pareto chart, I don't know how many of you are into sales or people who have worked at a bank. You see, sometimes you go to let's say a bank, and then someone who is supposed to look or see to what you are doing, you see that when you are done with whatever you are doing at the bank, they will tell you to rate the person. Sometimes some mobile apps too, they are on it. All these things they use. These are some of the data that they use to create the charts like this, the Pareto chart. Because if someone after serving you, there are some added things. For instance, if you come to the bank and then I serve you, what is the probability that if you go outside, you are going to tell someone else about how I served you? Or what will make you bring someone else to the bank? Or if you are selling something, if I sell something to someone else, what is the probability that it is going to cause how I service the person? What is my service to the person going to do to push him to bring in more customers to me?
Okay.
So all these things that we are learning, they are very important. So let's take them very seriously. Yes, please, you wanted to say something.
When you are doing the line, when you are plotting the line on top.
Yes, please. Yes, please.
We are going to locate the midpoint, right?
Yes. So so the at the top, it is not necessarily getting the midpoint.
Okay.
But it has to. You see, when we are drawing the bar chart, we have some width that we draw the rectangle for those particular charts. If between two, if you are choosing 2 and 3, or let's say one particular data point is, let's say 3, and its frequency is 17, you should make sure that the Pareto chart indicator for that particular, it is either in the middle or somewhere inside, like it has to be in that particular range. It shouldn't be outside. So the midpoint is really not so important. We shouldn't.
Are you going to just draw the line, or it must pass through some points?
Okay. So it is. You see that we are just getting data points. Okay. So
okay. So yeah.
Yes. Okay. Thank you, Doc.
Yes. So I think you have done very well, and yes, you have had a very fruitful discussion. It's almost over, but let us, because we want to be at the same pace, or we want to be doing the same thing, so that at least we are not marked wrong. In drawing we mentioned clearly that for the Pareto chart, it displays both the bar charts as well as it displays both the bar charts as well as the word, as well as the
line
graph. Okay, the line graph. And we want to say that because we have two graphs in one, the drawing the bar graph is not a problem, because the bar graph, you are going to make use of the categories with their corresponding frequencies. Somebody's mic is on. So for the bar graph, drawing the bar graph is not going to be a problem for you. But when it comes to the line graph, where you have to find the cumulative percentages, convert find the percentages of the various frequencies you have, and then after that you find the cumulative percentages. Now you are going to use the cumulative percentages to draw the line graph, and locating the line, because at any point in time there may be so many points on the line. So the conventional way to use the midpoints, use the midpoint. Just trace, make the traces to cut the midpoint, find the midpoint of the other, find the midpoint of the other. Now draw your straight line, draw the curve. You see that it will pass through. That will be more better than locating the points anywhere on the line. Okay, let's just use the midpoint to get them, and then we'll be free to go. So we are going to use this one as an example. This is a data that was given. This one, it was a customer service program analysis. So, like Arnold was saying, let's say a particular bank or a particular industry decided to look at the problems associated with their customer services. That is either going to bring in more customers or try to send away a number of customers. So the customer services, we have too much turnover. We have untrained staff. They have low staff compensation. These were the problems. So these were the issues related to the customer services. So some were, there were too much turnover. Some were untrained staff. Some of the problem that they identified was that there were problems related to untrained staff. And because of that, they were behaving the way they were, which might end up throwing some customers away. There were low staff compensation. Some of the staffs too were not happy, or they were putting up services that they were showing because of the compensation that we were given. Through to the last one where we have, there aren't enough phone lines. So when there's time for them to make calls and those things, there aren't enough phone lines to make communication easier. Now, let's now look at the various, these are not the percentages, okay, but the occurrence, okay, the occurrence, this one, okay, what we have here, this matches with this one. It matches with this one. Okay, so this is what we have this way. So we have the frequency count, or the frequency, or the occurrence count. So the first one, we have 190, 25, and through to the last one, which is 3. Now, can we convert the various counts that we have for the various service issues or issues relating to the services? So 190, for us to find a percentage of 190 out of the total, then we need to find the total. And the total frequency count was 268. So to get that, I know that one you can easily do it. So you just do it your 268. So let's do that one somewhere here and see 268. So you do it as what? 190. So you have your 190 divided by 268. Would that give us 70.90%?
Times 100.
So 70.89. So 70.9.
70.9.
If you round to 70.9.
No, did you get the 70.9 straight away, or you had
because I got 70.894. 895, sorry, 70.895.
Okay. So you multiply this by 100, so times 100
100%.
because we are converting it to, so times 100%, and that will give you. So you do that for all the various categories. You convert their frequency counts to percentages, and when you finish, sum them and see if you get 100. Then you move on to do what we call cumulative percentage. So the cumulative percentage, you know how it works. It's just like the cumulative frequency that we did. So the first one, you will not add anything because it's the first frequency that you have. But to get the cumulative frequency for the second observation, you need to add the first frequency to the first percentage frequency to the second one. So that will be 70.90% to 9.33%, and that is giving us a cumulative of 80.22%. The next one, you have to add a 3. So you have to add a 2 to get You have to add a 3 to get the next one. So that will be 170.90 plus 9.33% plus 4.85%. It's going to give you 85.07%. Or better still, you can use this one, what you have here.
And add the third one.
Yes, so you can use this. So you can just use this figure and then you add this. And you see that you'll be getting a total of this. So that is what has been done beautifully. Now, what we want to do, we want to draw or we want to construct a Pareto graph. We want to draw a Pareto graph. So Pareto graph, we said it's made up of 2 graphs on the same graph sheets. Okay, so we have the customer services, and then we also have the customer services. They have percentages or we have their frequency count. So that's frequency count together with their services or service issues. We can construct that of the bar graph, and that was what was done there. Okay, so if you see what we have here, Arnold made a point. He said, make sure you arrange the data in this descending order, right? In descending order. So if you look at what we have here, you see that the data has already been arranged in descending order.
Yes,
that is why, yes. So the 190, the frequency 190 is more than the one with the 25. So it has been arranged in descending order from the highest to the lowest. Okay, so now that you have made that observation, it means that anytime the data is given to you and it is it's not well organized, it's not arranged it's not arranged in the descending order, you need to do that so that you can have the cumulative frequency drawn, the cumulative percentage frequency. So now we come to the bar graph. That one we said you can easily do it. So each of the bars, so you use because the highest this thing is 190. So if we use 10, 10, and this one credit we use 20. So 20, 40, 60 up to 200. Okay. Now the bar graphs, we have the first one, which is the first one has what? 190. So 190 is a bit above. If you look at 190, this is yes. So this is 190. So you can see that here. Yeah, so 190 is in the middle of the 180, and that will be 10 plus that. Now, the bar, we have finished drawing the bar graph. The next one is the accumulative percentage frequencies, accumulative percentages. So accumulative percentages, what we do? So we start, this one, we need to scale it. So we start with 0, then the next one is 10, the 20, 30, up to what? 100. Because the cumulative cumulative percentages is supposed to sum up to 100. Now, because we started from, we have arranged the data in descending order, you realize that the first one, which is 2 months turnover, the cumulative frequency was 2 months turnover, the cumulative frequency was 70.9%. So I said that because reading the 70.9% on this graph is not easy, let's make it 71. So we are going to look at, so this is the 2 months turnover. So the 2 month turnover, let me see if I can use mine. So the 2 month turnover, I mentioned that we should use the class midpoint. Okay, so the class midpoints will be somewhere in the middle. So let's say this, the middle. I've just started using the app, so that's how it is like that. So I hope you agree. You forgive me. Now, we needed to get 71. So you trace this one. So you see the 70, look at where the 70 is. So the 70 is somewhere here. If you look at the 70 is somewhere. So the 71 will just be slightly, okay, above the 70. And that is considered as the point that we have here. So that's where we have the first point here. the first point here for the 2-month turnover, the percentage cumulative, the cumulative percentage for the 2-month turnover is 70.9. So this is a 70.9. The next one is what? Untrained staff. So let's look at the untrained staff. The untrained staff, the cumulative percentage was what? 80.22. Just make it 80. So let's go to the graph and see if we can get 80. So you trace the midpoint. So trace the midpoint of this. My hands are. So you trace the midpoint here. Okay. Now you trace this. You see that it's on the 80 exactly. Look at it. It's on the 80. Please, are you following?
Yeah, we are following.
Yes, so that is how. So that is how we draw the next. We get the next point. So it's at the midpoint. So that's the 80.22. But let's say that it's 80. Now the next one is the cumulative frequency for the next one is what? 85.07, isn't it? So this one 85%. So let's go and look for 85. Let's go and consider 85%. So that is for the next bar graph. So the next bar graph too, we have to trace the middle. So tracing the middle, I'm not too sure if it is here, but William is saying I shouldn't go anywhere. It is here. So this one, when we trace it, when we trace this, I wish, hey, my hands are not straight proud. Okay, I'm getting some line. Can I raise it a little bit? In the middle, right? 85. It's supposed to be here. So, and if it is there, like it would have raised the line from where my line is. It would have raised it up a little bit, but I'm not able to. It's supposed to be in the middle here. This is the 85. So somewhere here. You are not clapping for me. I've done it. So please, are you following?
Yes, please.
Yes, please.
So the 85 is the last line that I've done. So you see that it is exactly on the points, at the midpoint here. I'm not too sure if that is the midpoint. The midpoint may be here. Yeah, but what I know is that they are on the line. So it's there. So that is the 80 points. So can you do the rest? Look at the rest and see if you can do the next one. The next one is supposed to be 88.81. Just make it 89%, 89%, and see if where the 89% is, whether it's good. That is no standard systems. Is it okay? Please, can you draw the Pareto chart now? Can you draw it for me? When you have the slides, can you do it yourself now?
Yes, sir. Yes, sir.
Yes, sir. Yes, please.
Okay, so we can move on from here because, yes, I think you can do it. The online. Hey, so even my students, those from UCC Center, they are more than 40. But if I look at the number here, hey, Atanyungo.
Even you quite okay.
You have considered me.
We're 13.
Hey, then you have considered me, pa.
In the first class, we're 13.
Okay, you have considered me. Thank you for considering me. So the next thing is the stem and leaf plots. Please, the Pareto chart.
Sir.
Yes.
Sir, please, my hand is up.
You ask your question.
Sir, please, so here, if I understand, it means that the curve that is there, we are going to use the cumulative percentage to draw that curve.
Yes, to draw that curve.
Okay, sir.
And the point that you will be using should be at the midpoint of the bars. Trace it to the midpoint. The midpoint. So there's the midpoint that we are tracing to where the cumulative percentage point can be located. The intersection is where we labeled as.
Thank you,
So
sir.
that is you are welcome.
Okay.
Yes, Eric Ahin. Eric Ahin.
Sir, please, I also want to find out whether you draw both the line graph and the bar one on the same graph.
What do you think? I've said it already. What do you think? What do you see here? Do you see one at Elimina? Do you see one at Elimina and the other one online? They are on the same graph. Okay, that's why they are using two different scales. So you see the counting, the normal counting, the normal frequency on your left, and then the percentage frequency, the cumulative percentage frequencies are on your right hand side. So they are on the same graph.
Okay, sir.
And open your eyes. Open your eyes. Now we come to the stem and leaf plot. Stem and leaf plot. For this one, you have been doing it, so you can easily. The first thing you have to do is to order the data, choose the stem and the leaves. Be sure to include a key. So the key would interpret the stem and then how the leaves will be obtained as well. Then you write the stems to the left of the vertical line, and you write the leaves for each of them to the right. If you turn them the other way, we'll call it how do you call it? Tautology, right? So, or we'll call it a misconception. And such a misconception, if it is committed by a teacher like you, I don't think you should be forgiven. You get straight A. Go and try it and see. So look at this one. We have the height of basketball players. And we want to make a stem and leaf plot for the data. The key, we have drawn our vertical line. We have drawn our vertical line. We have indicated where our stem will be, where our leaf will be appropriate. Now, the key will tell us which one we are starting first. So this is the key. So usually you use the smaller number. You can also use the bigger number as a key, but it will be more easier using the smaller number. So I would say the smaller number here is 69. So in the 69, my 6 is the tens and my 9 is the ones. Now, the question they will ask you is that how many people are involved in this? How many people do we have for this data? Those are some of the questions they can ask you. For instance, look at this. So the stem and leaf plot shows student test scores. How many students score less than 85 points? Please, can you answer that question? Look at it and answer it for me.
Sir, 10.
Did you raise your hand? Next time.
Yes, my hand is up.
Okay, who called you? What about the B part of the question? How many students scored at least 90 points? At least 90 points means 90 and above, isn't it?
Yes, please.
So you have 1. Oh, how many? Answer that question for me. How many students scored at least 90 points?
4, please.
4. Okay. How many of you had 3? Show by hand if you had 3. Okay, so nobody had 3. Then we come to the box and whisker plot. So this one, you look for a box and then you look for your whisker. You now have form what we call box and whisker plots. So box, here you are. Whisker, here you are. Now box and whisker. So the box and whisker plots offer a pictorial summary of important data set characteristics, including displays some of these characteristics of a data set: the central tendency, the dispersion, the asymmetry, the extremes, the percentile rank analysis, and you can also find the maximum and the minimum values for that data set. So now let's see how we can represent that pictorially. So here you clearly see that this is this part of the whisker shows the lower value. So the left side, the longest tail that we see, the end here shows the lowest value. So to read it, you have to trace it down. And it's a star, isn't it? So you have to trace it down. I will not remove it. I will, hey. Go ahead. So we will trace it down and then we read. Okay, so you trace it down and read the value. So you read the value. If it is maybe 30, you note that the lowest value is 30. Now we have this part of the box. Okay, this part, this line shows the line of the lower, shows the lower quartile. Okay. So where is the lower quartile? So we have, let's see something. We have 1, 2, 3, 4. So this shows the lower quartile. And then the line here, this line here shows the median. So this shows the median. So what it means is that if this is the median, then it means that half is this way. Sorry. So it means we are half this way. This way is half the data set. And then from this midpoint, this way is also half. So check the measurement and see. I think yes. So the line here shows the midpoint. Whilst the line here shows, okay, shows the lower quartile. And the point here is the width of the width of the box shows the interquartile range. So let me do some cleaning. Okay, so then we have this, the line here, the line up here, the line that we have here this way. Also, the line shows what? The upper quartile. So the upper quartile, we said it is 3/4 of what? The data sets. And then we have the highest value. So this will also give us the highest value. This part of the data will give us the highest value. So you read, to get the highest value, trace it and read it down here. Read it down. Okay, so any question on the box and whisker before we move on? Now, let's look at the example, a typical example of this box and whisker plot that we have here. My focus is going to be on, say, what does the 50th percentile means? What are the 50th, the 25th percent? What does it mean? Okay, the upper quartile, what does it mean? Those things are the things we want to. So at the top, where is that this thing that we were here? So the top here we have the maximum value and which is the greatest value that you can talk about. Then we have the upper quartile. The upper quartile, we said it is usually, the upper quartile is usually 3/4 of the data set, 3/4 times summation F. That is
No,
if it
that
is.
should be 75%.
Yeah, that should be 7. And oh, you are right. Yes. So the upper quartile is 75%, not 25. No, but the interpretation here too is right. Okay. Yes, the interpretation is saying that the upper quartile, if you have the upper quartile here, if we want to say that it's 75, it means that 75% of the scores falls below the value, the upper quartile value that we'll be reading. But what they have done here, it means that 25% of the data, it falls above. Okay, so it's correct. I hope it's okay.
Yes, Doc.
Yes,
They are
sir.
looking, is the interpretation. But we know that after the upper quarter, we know that is 75%. That is good. Then the median is 50%. And then the lower quarter is 25%, right? But the interpretation they are giving here is somebody's mic is on. So the interpretation is right. So now let's pay attention to the interpretation since we know the percentages that somebody's mic is on. Since we know the percentages that we can ascribe to the various patterns. So if we get, if we say that the first quartile is 25%, what does it mean? So if you find the first quarter value, let's say 31, okay, the score was 31. That 31 will tell you that 25% of the scores falls below the 31. Is that okay? We are talking about the lower quarter, which is the Q1. If you get a Q1 value of 31, it means that 25% of the student's scores falls below the 31. I hope that is clear with you.
Yes, please.
Now, when we go to the median, which is the 50%, it simply means that 50% of the marks falls below and then 50% also falls what? Above. That is what it means, right?
Yes.
Now, the 70% means that if you, the 75%, which is the upper quarter, means that 75% of the students' scores falls below that value that you have read. Are you following? If 75 falls below, then it means 25 falls above. I hope that is clear.
Yes, please.
So that is the interpretation. The interpretation is very, very important. It's not about the calculation, the interpretation. Now let's go to this example. Hey, but I'm still worried about your number. The online people, are you here? Hey.
Yes, please.
Yes, please.
Yes, sir, we are here.
Not all of us.
Yes,
not all of us.
yes, sir.
So it's my students who are not here. Okay.
Yes, sir.
So we are
Yes,
here.
sir.
Exactly.
So we are here. The students are here. We are here.
I have a friend among you. Let me mention your name and see. Elizabeth. Lizzie.
Present out.
Hey. Face to face. Lizzie didn't show. This one, she promised to be here. Okay. Okay. Yo.
The online Lizzie is here.
Lizzie, are you sure you are the one?
Some online Lizzie.
Yeah, okay, online Lizzie is here. I'm talking about face-to-face Lizzie, the one from UCC Center. Okay. Now let's find the the median for this data set. The median for this data set. You see, for you to find the median or the first quarter, the third quarter, and so forth, we need to arrange the data set first. So first, arrange the data set, right? So we need to arrange the data set first. So let's look at the data that we have here. They are student scores. Is the data set arranged in ascending or descending? Is it arranged?
Yes, please.
So it's arranged. Now, can we find the lower quarter? But before we find the lower quarter, how many observations do we have here? 2, 3, 4, 5, 6, 7,
9, 8,
15.
90.
Says 15. 15.
15.
It's 50. Yeah. So because the number of data set is odd, we have to make it 1/4 times summation f plus 1. So you find 1/4 summation f plus 1. Okay. So that will be 1/4 times. You said 15. 15 plus 1 will be what? 16. 16. So 1/4 of 16 is what?
4.
Now count the fourth observation and see if that will be the lower. If the lower quarter will be 52. Count the fourth observation.
Yes,
Is it 52?
Yes, please.
Yes,
So that is how we had the 52 as the lower quarter. Okay, it's 1/4 of the number of observations, and here the number of observation is what?
15.
Is 15. But because 15 is odd, we have to make it 1/4 n plus 1 observation. 1/4 of n plus 1 observation. I hope that is clear. But if it is even already, you don't have to add 1. Is that clear?
Yes, please.
Okay, so can we find the upper quarter? The upper quarter will be 3/4 summation f plus 1. So do that and let's see if you get it.
12.
That will be the 12th observation.
12.
So count
the
12th observation, either in ascending or descending order. Hey, we should count it in ascending order. Don't count it in descending order.
87.
Yes. So here the arrangement should be in ascending order. Descending order would not. So it's 87. Is that correct?
Yes,
please.
Yes.
Okay. So it means that our lower quarter is what? 52. And our upper quarter is what?
87.
87. Can we find the quarter range? The quarter range, which is the upper quarter minus the lower quarter.
That will be 8.
That would be 8. Okay, that would be 8. Okay, so that is that. You are yes. Any question?
Yes, sir.
Yeah,
Sir,
I
please,
see it.
Sir, please, I want to ask
go ahead.
if the median can be found by subtracting the Q1 from the Q3.
How do we call that one?
The subtracting the lower quarter from the upper quarter, like the position. The position for Q1 was 4, and the position for the Q3 was 8. 12 rather. So when you subtract it, you get 8. So 8 position will be the median.
Okay.
So can it be read that way? Hello, sir.
The median, what we know is that the median is half summation f plus 1 observation. So half times 16th observation. And it matches with what you are saying.
Yes, sir.
So it's, yeah, you are right. Any other question? Whose hand is up? Me, I'm not seeing. Eric.
Sir, please, can it also be that when the numbers are odd, can you also find the median by from the in the middle straight ahead? Because
Yes,
from the
yes. By that one, you have to arrange the data first.
yes,
It
please.
must, yeah, it must be arranged in ascending order.
Okay, sir. Thank you.
So can we move on?
Yes, sir.
Yes, sir.
Histogram. Here we come. So the next graph that we want to use to summarize or organize our data is the histogram. And the for histogram, you know, is similar to that of the bar graph. Just that the histogram, we don't have spaces in between the bars, right? So while the horizontal scale is quantitative and measures the data values. So you can do that, especially we use that for the, group data. Let me say that you have to work examples on group data that has unequal class size. Please, can you hear me?
Yes, please.
Yes, sir. Yes, we can hear you.
A question has been set on that for you. Hey, do I have to say what I have said? Hey. With the but what I want to say is that you need to look at examples, work on examples that have unequal class interval, that uses unequal class intervals. How you can use that to construct a histogram, okay, and find the midpoints, those values. Okay, so let's see this one. So this is the histogram. We have the group data, but with the histogram, you can use both class midpoints and what? Class boundaries to construct a histogram, isn't it? Please.
Yes, please.
Yes, sir.
But when we come to the cumulative frequency curve, use only the class boundaries. Don't use class midpoint. You'll be marked wrong. I hope that one you are aware there too. You are aware. So
yes, sir.
So this one, the lowest class was what? The lower class boundary was 4.5. So you see that this class didn't start from 0, but no marks was left behind. Ideally, there should be some marks left for you to do that. So 4.5. Then the next one is 9.5. Then 14.5, 19.5, 24.5, then 29.5. So that is that. Then for each of the bars, you match it to their corresponding frequencies, and you are there to go. And this is for equal intervals. But I am charging you that you read on examples that have unequal class intervals. Now we come to unequal intervals. Okay, I think we have some here. So with the unequal intervals, most of it comes in relative mass. Okay, so the unequal intervals, we have that one to the data should be grouped like what we have here. This is a group frequency data. So we have the various classes with their corresponding frequencies. We need again to get a class boundary, and then we need to get a class size. When we get a class size, we are going to compute what we call frequency density. That is each of the frequencies divided by its class size. So each of the frequency divided by its corresponding class size. Well, what we want to do is to come out with a histogram with unequal class interval. So now, if you are able to do that, if you're able to come out with the various frequency densities, then we are going to match that against the class boundaries. Okay, so to construct or to draw or to plot our what? To plot our histogram with unequal class intervals. Please, is that clear? So with the histogram with unequal class interval, it is the class boundaries against the what? So what it means is that on the side of the vertical side of the bar, we are going to use frequency what? Density. Whereas in the other one, remember, we use density and we use frequency against the class boundaries. So that is what we are going to check here. So check this out and see whether. So look at the class boundaries again. And look at them. So you see that this class, the last class, 35.5 to 55.5, you see that it's almost twice or even, yes, twice of some of the classes. Any question on the unequal? So here, what we have here is frequency density against the class boundaries. Any question on constructing how do you call it? Histogram with unequal class interval. Any question? Yeah, wait, let me call you. I've heard of you. Yeah. Okay, let's go to Joseph Atta Penny.
So, sir,
I know him very well. So, yes.
So, sir, the intervals will depend on the graph, right?
Which intervals?
No, from 0.5 to 5.5, 10.5, 15.5, 25.5. We depend on how you scale the graph, right?
No, it's the class size. Those are the class sizes we are using. Look at it. We have the class sizes here. These are the class sizes. Okay. So if you look at the class size, you see that this one is 5. This one is also 5. This one is 5. So the first three, their size is 5. But the other one is twice. And the last one is 4 times bigger as the first ones. Okay. So let's go. This one. I follow him. This one, yes. So the number of people in this class is 5. But the number of people in this class is 20. So that's why if you do 55.5 minus 35.5, won't you get 20?
Yes,
and 25.5 minus 15.5, the number of people here is also 10. Whereas the other one, the number of people are what? 555. Are you getting it? So it's the size that is used down, the size. That tells you how big the bar should be, how big the graph should be, how wide the graph should be. Please, did you get that? This is the class size that tells you how wide the graph should be. Is that okay?
Yes, please.
Yes, sir.
Frequency polygons. We come to frequency polygons. Frequency polygons. So So for frequency polygons, we will have, just like the way we drew the histogram, we are going to have lines on the histogram, okay? So here we have the class boundaries, then the class mark. With the frequency polygons, you are also good to use the class boundaries, right? So this example of this is the frequency polygon for the data set that we have here. You see that we have drawn the various histogram. Okay, the histogram is drawn. Then a line, you see we have a line. So this line is at the midpoint. So it's at the midpoint. So just indicate the midpoint. Come here, get a midpoint. Come here, get a midpoint of this bar. Come to this one, midpoint. Come here, midpoint. Draw a line to pass through the midpoint or to join the midpoint. You have drawn a frequency polygon. But this is not your final frequency polygon. Remove the graph, the bar, because the bar graph helps you to, the histogram helps you to get the line accurately. So now remove it. When you remove it, now it looks like this. So this is a frequency polygon. Can we move on?
Yes, please.
Can we move on?
Yes, please.
Sir, please, I have a question.
Next time, if I beg you before you ask a question, sir,
I'm sorry.
Next time, if I beg you again before you ask the question, I will not answer your question. So take note of that.
Sorry, sir.
Now ask your question.
Sir, my question is, it seems we use the histogram to draw the frequency polygon. So I want to find out if we can also use either a bar chart to also draw the frequency polygon.
Let's ask AI and let's see.
Okay.
So ask AI and give us the feedback.
Okay, sir.
Because what I'm seeing here is when the data is grouped. Okay. The frequency polygon, when that even comes in, we should have a large data set, right? That's because of the large data of it, we have to put it in categories. So you ask yours and let's see. Ask and let's see something.
Okay, sir.
What are you getting?
I'm now working on it.
I'm encouraging you to use AI. Where do you get it? Anof, what did you get? Did you remember his question?
Sir, he said that. Hello, sir.
Yes.
He said that a histogram is more suitable than a bar chart for drawing a frequency polygon because histograms represent continuous data. However, if the bar chart represents grouped numerical data, you can still use it to construct a frequency polygon.
If it contains what? If the bar, however, if the
bar chart represents grouped numerical data,
okay,
you can still use it to construct a frequency polygon.
Okay.
So
that is fine.
So that is what I got. Yeah.
Okay. So
okay.
So are you okay now?
Yes, please. Yes, please.
So next time ask AI.
Thank you very much, sir.
Next one. So now we come to the cumulative. Please, the one who has the question, that does not mean you should not ask questions. Cumulative frequency polygon.
Yes,
so this one too is a common one. So with the cumulative frequency polygon, it's also something that is common, and they can ask you to, they can examine you on that. The cumulative frequency, how do you call it, the frequency polygon, you can be examined on that. There are some of the things that you may use them, but not very, they may not test you so much on that during the exams. Okay, so but you have to read on them. So the cumulative frequency polygon, which you have been doing already, you need the max. Okay, you need the max. Hey. So you need, I was holding my pen and I is doing that. So you need to have the class boundaries. If you are drawing a cumulative frequency polygon, you need to have the cumulative frequency polygon or ogive. That is what we are talking about here. Are we right?
Yes, please.
Yes, sir.
So get your class boundaries, get your cumulative frequencies, and then now your cumulative frequencies against your class boundaries, you are good to go. Don't use the class mark nor the class midpoint. None of them is going to help you. So this is an example we have here. So we have the cumulative frequency on the left side, or on the vertical axis. Then we have the max. This one, you need to find out too. When we are marking WASI, they will tell you that the students are not supposed to use class midpoint. Please, let's ask AI. Let's ask that right now. Are you asking?
Sir, please, whether we are supposed to use the midpoint.
Ask whether in constructing the cumulative frequency polygon, it's advisable to use class midpoint against the cumulative frequencies. Ask why it is not advisable. Because when we were marking, or when we used to teach at they will tell us that what we know is that in constructing a cumulative frequency curve or the ogive, students are not supposed to use class midpoints. So anybody who use class midpoint, the person will be marked down. Let's find out why. Arnold.
Hello, sir.
Arnold, yes. Can you take charge, brainstorm with, when they get the feedback, you have 5 minutes to talk about it. I'll be with you soon.
Yes, please.
All right.
Hello, please. If you've gotten any submissions, you can raise your hand so that I can call you. Hello.
Yeah, we can hear you.
Okay, Watson, have you gotten anything?
Nah, still on it.
Okay. All right. So, Joseph, please, you can speak. Hello, Joseph. Please, if you've gotten anything, you can. Okay. Please, you can speak. Eric,
Okay.
you can speak. Yes.
Yeah, what I heard is that they said the class midpoints are sometimes used as approximations when the class boundaries are not available. But however, they are not the best choice for a proper cumulative frequency curve. So it means when the class boundaries are not there, that's why you are compelled to use the class midpoint for it.
Okay.
Thank you.
Okay. So the class midpoints are normally used as approximations. Okay. Please, any other? Please, if you've gotten anything, you can raise your hand so that I can call you. All right, so I have here, mine said that I asked in constructing cumulative frequency polygons, is it advisable to use class midpoints and why? And it said that no, it is not advisable to use class midpoints when constructing a cumulative frequency polygon or OGIVE. And it said that why class midpoints should not be used. A cumulative frequency polygon shows how frequencies accumulate up to a boundary, not within a class. Therefore, cumulative frequency is associated with class boundaries, not midpoints. Using midpoints gives a false position for where the accumulation actually occurs. So we are looking at intervals. So if you are using midpoint, it's like you are basing it on some particular point within the data set. So it also says that it can lead, using the midpoints can lead to wrong interpretation, especially when reading medians, quartiles, and percentiles. What should be used instead? So instead of the midpoints, it says depending on the type of OGIVE, if you have less than OGIVE, plot upper class boundaries on the horizontal axis. Then
Okay.
plot cumulative frequencies on the vertical axis. So please.
Okay. Yes. So what was the most important points that you gathered from the research that you did?
Yeah. So it was said that using midpoints is almost like using an approximation. Midpoints are giving fixed points, which means it is not the best. It is not the best advice to use the midpoints in getting it, but rather using the class boundaries will help.
Okay. So please always use the class boundaries against with that of the cumulative frequencies for the cumulative frequency polygon or the OGIVE. Today is Christmas. This isn't it? We are in the Merry Christmas. Merry Christmas to you all.
Merry Christmas.
Merry Christmas. Merry Christmas to you all.
Merry Christmas, sir.
Those of you who are around, you can pass by. Okay. So we would so that is that for unit 2. Okay, that is that for the unit 2. What is left is for you to, so that is that for the unit 2. We'll end it here and we'll continue in our next lecture with the unit 3. But then the unit 3 will be shared, will be given to you ahead so that you read on them before our next meeting. And when we meet and you have any key issues you want us to discuss, we can quickly discuss them so that we can move on to the unit 4. Can we bring the curtain to, can we draw the curtain down, or we should still pull it up?
Sir, please,
let's bring it down.
Sir, please, this particular slide, you are here to share it to us.
Okay. We are in a festive season. Today, I made my mind I will not teach. What is this? I even made my mind I will not teach. I'm telling you. So today I've been with you from morning up to now. I've done well. See you. Bye bye.
Yes. After this week, after 2 weeks, we are going for quiz.
Yeah, you are going for quiz. Motivate.
Please show yourself for we the online teach people.
Who are around out there? Oliver, if you are around, let's go.
Oliver,
Sir, please, you were saying something. Sir, please, you were saying something.
Yeah. I said you remind me to get a slide for your colleagues.
Yes, please.
Okay. Today, I think Madam Aduma is here, so she is good at that. So she will take it and give it to you. Okay. So all the best.
Yes.
Bye bye.
Madam will continue from where you ended.
Bye bye.
Bye.
Oh, already
Today we didn't
yeah,
cook at all.
yeah,
Wow.
Hey, Jesus.
Mr. Boatin somewhere. And then it's Reno. Oh, Sirio. Hey.
This one look right.
Hey.
We call it overload. Overload.
Overload, Agaza.
Aka 4 units, 2 weeks for quiz.
So when are we writing the first quiz?
In January.
The January what? 2 weeks.
After next 2 weeks, the following week is a quiz.
So next 3 weeks.
3 weeks, yeah. 3 weeks.
Diana, boys in class no mama class no. Mama.
Boy, oh, mama.
Oh, yeah, pretty you.
This was like,
Meaning you finish with only 4 units for the quiz. After the quiz, next week, semester.
You ought to trust this 4 units. I did our last quiz of the year. Wow. It's in Nama.
Dr. Yapa said the question to be.
Actually, I don't know. What do you call it? Advanced algebra and calculus. Meanwhile, we haven't talked about the calculus. Yeah, that's what advanced algebra. Charlie.
Questions, don't forget that to come from all sectors.
No dear.
So, to say you're quite transition, yeah, dear.
So, Mate, dinami jam.
Okay.
So, when you are here, dear, near Corona, some neighbor.
I beg, my friend, I beg.
Now, what did you mean? What did you mean? What echo? You never found call. You never found call. I was a more.